All right, let's end up the fun with lipids and proteins. Okay, so the phospholipid bilayer. I know you're excited. I know you love the phospholipid bilayer. Who doesn't? Right? We got some hydrophobic, hydro, water, scared, phobic, scared of water tails, and some hydrophilic, I love some water, heads, right? And they form this little bilayer because their hydrophilic heads face out and their hydrophobic tails face in, creating sort of a waterproof barrier. Okay, made out of lipids, by the way. There are a bunch of types of lipids. You have fats, triglycerides, 3 glycerides. You have phospholipids, you have steroids, and waxes. Here's a little treat of all these things. Triglycerides are formed from the condensation of 1 glycerol with 3 fatty acids. 1 glycerol, 3 fatty acids. Triglycerides, right? Phospholipids are a major component of plasma membranes and are made up of 1 glycerol that combines with 2 fatty acids. Right? Phospholipids, 2 fatty acids. Triglycerides, 3 fatty acids. I feel like you can get that on a multiple choice question, right? Steroids are lipids that do not contain fatty acids, and they are like cholesterol, testosterone, estrogen, progesterone, and waxes are a molecule of alcohol that combines and makes things waterproof, like leaves and otter's fur. Okay, again, lipids store a lot more energy. They store energy more than 2 times the energy per gram than carbs. That's why bears don't carb load before they hibernate. Bears fat load before they hibernate. And this is, again, your lipoprotein, lipase, and triglycerides. Your body stores fat in adipose tissue because it will keep you alive in a zombie apocalypse situation. So in terms of comparing lipids to carbohydrates, this is a long-term energy storage situation. They are less effective at osmotic pressure. They are less easily digested and are usually used for aerobic respiration. They store twice as much ATP per molecule, and they are not water soluble. Okay, starting out strong with steroids and cholesterol. Okay, this is what a steroid skeleton looks like. All of your steroids are going to look like this. They're going to be 4 fused carbon skeletons, even if you are terrible at chemistry. Friends, this is a ring. This is a carbon skeleton ring. 1, 2, 3, 4. See, you got it. You got steroids, you can do this, okay? Cholesterol is a fluidity buffer. You'll see in the phospholipid bilayer that they are in there, those little cholesterols in there, and it keeps your phospholipid membrane from becoming too rigid. I'll show you a picture of that. It's actually really quite cool. See your little fluidity buffers in there? So there they are. There's your little cholesterol buffers, and they just keep it fluid, if you will, and preventing the membrane from becoming too rigid. And you can see their little ringed structures. That is a cholesterol in your phospholipid bilayer, keeping everything nice and fluid. Okay, let's talk about protein. What is protein? Protein is amino acids. Where do amino acids come from? DNA, right? DNA to RNA, RNA to amino acids to protein. Okay, amino acids are the monomers. Proteins are the polymers, right? It's almost like this whole test has a theme. These are the monomers. They make a chain of amino acids called a protein, and then we fold stuff. Let's fold. Okay, hold on. Okay, we did this in class, remember? So after we make our string, each one of these beads is an amino acid, okay? We can make an alpha helix. We can wind it around and it'll make a little helix, okay? Another option is to make it into sort of this fan structure, this beta pleated sheet, okay? So your primary structure is this, your amino acids. This came directly from your RNA, right, and translation, okay? Immediately after translation, because of the chemical bonds and how they bond together, it winds around in a very specific way. That is secondary structure, okay? We're here, secondary structure. Now, tertiary structure, you're going to fold this like over on itself, okay? It's it's at its core a helix, but then it folds onto itself based on chemical bonds. Same here. It'll fold over on itself. Okay? See that? That is tertiary structure. Okay? And quaternary structure, you're just going to put things together, right? I'm going to put a bunch of beads together. Okay, let's look at that. Primary structure, string of beads. Secondary structure, wound around. Tertiary structure, folded like your fingers over on itself, or folded like this. Quaternary structure, I put them all together. So, remember, we talked about hemoglobin. Let's talk about hemoglobin. One difference in DNA creates the wrong amino acid. Means the secondary structure doesn't form correctly. Means the tertiary structure doesn't form correctly. Means your heme is sickled from one difference in your DNA. One mutation causes this, all of this folding to be wrong because the chemical component of your amino acid is wrong. It coded for the wrong amino acid. And now everything after that isn't folded correctly. So you have primary, secondary, tertiary, quaternary structure. Okay? Proteins have 3D shapes, and they are very often enzymes. There is an active site where the substrates fit together, and that lowers activation industry. I had a picture here. I have no idea where it is, but we're moving on anyway. Okay, this 3D shape creates an active site, and that's what brings it together. Okay? So the two chemicals are out here, but the enzyme sort of connects them together. That is called an active site where the substrates fit, and that lowers the amount of energy that it costs to make that happen because you're setting right together. Nucleic acids, DNA and RNA. Glycoproteins are proteins with carbohydrate tags used so the immune system recognizes them. We are not going to go into the immune system. Just know that that's another type of protein. Okay. Lipid digestion. Let's roll through this, okay? Lipids. This is, fat. Okay, so a small amount of lipid digestion occurs in the stomach, but not till you get there, right? I mean, some mechanical digestion occurs because you're chewing up. And then we're really not doing anything until you get into the stomach, where you have some gastric lipase. Lipase, the enzyme that breaks down lipids. You probably could have gotten that. Then you've got bile, right? You've been waiting. You've been waiting for the pancreas. The pancreas is back. The pancreas is going to inform the gallbladder where your bile is stored. It's made in the liver, stored in the gallbladder, and that's all going to release here into your duodenum, right? Here's your pancreas. Here's all where the gallbladder and the liver come into your duodenum to release it into your small intestines. And that's going to aid in the digestion and absorption of lipids. Then pancreatic lipase in your pancreas is produced by the pancreas and released into the small intestine to break down specifically triglycerides into monoglycerides. Okay? Now, then we're like zooming out. Okay? Here's your bile. Do you remember the micelle? Just like soap, it's going to come and surround it. And your micelle is going to move into the microvilli. What? Where's the glut? Where's the sigil? Where's it? It's fine. Remember, because like you're a fat, I'm a fat. You hate water, I hate water. We're cousins. Just let me in, man. The cell's like, come on in. Yeah, it's fine. And just like, it's fine. Then we're going to get processed and we're going to go not into the blood because you're too fat for that. You have to go into the lymph. Okay, do you remember this? Let's review. You're in the small intestines. You produced bile from your liver. It's stored in your gallbladder. You got released into your small intestines. Lipase has broken you down into fatty acids and glycerols. And now you need to get yourself into the blood. You're like, oh, easy. I got to make myself a micelle, right? The micelle just goes right in because I'm a fat, you're a fat. Let's do this. Then I get processed, right? And then the Golgi processes me, the whole thing, and exocytoses me out. Boom. Bada boom, bada bing. Let me in. Capillary's like, no, I'm sorry. You're too fat for that. The lacteal, right? Here's your lacteal, is like, come on in, welcome to the lymphatic system. And there you go. Let's look at another picture before you see mine, which will be superior. Bile salts. This is the whole point of your gallbladder. It's going to emulsify, create micelles like soap. You're going to go right in, right? You're going to go right in because you're a fat, they're a fat, you're best friends. You're going to go into the smoothie R, right? And they're going to kind of like process you, check your passport. Then you're going to get packaged in the Golgi. The Golgi is going to give you some packaging that will allow you to be exocytosed. You are denied access to the capillary because you're too fat for that. So you're going to go into the lymph. The lymph is going to take you to the vena cava, which will put you eventually into the blood system. But you're not going to go here because you're too fat. You got to go through the lymph and like make sure you're not sketchy. Okay, and here's mine that, let's be honest, looks exactly like the other one. Right? You got glycerol. You're broken up by bile and lipases into fatty acids. Your smooth endoplasmic reticulum is going to process you. The Golgi is going to package you. You're going to get exocytosed out. The capillaries like you're too fat. The lymphatic system is like, welcome to the lacteal. Right? Onto the vena cava. Here's just another view of that. Same situation. Oh, I'm sorry. That's your amino acid transporter. Okay, so that is how you are going. This is how you are getting your fat. Okay? This is how you're getting your fat into lacteal. Let's talk about your protein real quick. Okay, proteins. Proteins break down into amino acids. Can we agree on that? Okay, so you have a protein, it's broken down into amino acid. Now, there's a couple of options for that. One is a single amino acid. That's what we're going to go with right now. Your amino acid is going to go in through a transporter. There are 20 amino acids. There's like 17 different transporters. We're not going to talk about each one of them. I don't want to do that. You don't want to do that. Nobody wants to do that. It's an amino acid transporter. It's a co-transporter with sodium. It's a sodium amino acid transporter. That's going to go in. Of course, once I say sodium, you already knew sodium potassium pump. Absolutely. There's a sodium potassium pump involved, and that transports them out. They can go directly into the capillary. Okay? It's kind of it's not very difficult. It is if you have to draw out each one of these 18 amino acid transporters. But for the purposes of this, going in sodium potassium pump, right? Going in sodium, got to have a sodium potassium pump. That's running your sodium and potassium. And then you're just coming back out from that transporter into your capillaries. See? And mine looks exactly like this. Right, here's your sodium ion. Here's your amino acid transporter. You got a sodium potassium pump running this whole thing to get your sodium gradient working, and you have another amino acid channel protein, and it goes right into the capillary. That's like crazy easy compared to the rest of them, right? Nuts. And also you have facilitated diffusion, and active transport, because that's a sodium potassium pump. Here is again what that looks like. You also sometimes have dipeptides, and that's going to be a little bit of a different process. You got a transporter, and you're going to have to exocytose that out because you're a giant polypeptide. Okay? And there again is, I just have one where I include your polypeptide, which is more exocytosed than not. But ideally, this is the one I want you to know for the test. It's the easiest one, so it should be pretty easy. Okay? Wednesday, we will review. Also, I'm telling you this on here, and I will tell you this on Wednesday. I will give extra credit, somewhere between 3 and 5 points of extra credit on this test. It's going to be bring a beverage, anything but a water bottle, right? You can bring a watering can if you want. I may be drinking out of this watering can. Anything that you might be able to drink out of that's not a water bottle, I'm giving you 5 extra points on Friday. Anything but a water bottle, you're drinking out of it. Good luck to you. If you watch the videos to the end, then you know that you get 5 extra points for anything but a water bottle. All right. Email me if you have questions.